Hello, everyone. Today on Geoscientist Voices, we are exploring the intersection of hard data and public safety. And I'm joined by Damiano Koxhaj, a researcher at the Institute of Geosciences in Albania. He specializes in using modern data analysis to understand earthquakes and, crucially, how to communicate that risk to the public during a crisis. Damiano, thank you so much for joining me today.
Thank you for the invitation. It's a pleasure.
Damiana, you work specifically on near-fault seismicity, which is often where the most intense damage occurs. For the non-seismologist watching, why is the physics of an earthquake different when you are right next to the fault versus when you are 100 kilometers away from it?
Well, at first, it differs because of the intensity of an earthquake. Like, for example, if we have an earthquake and we are 1 kilometer away from that, the intensity, it's not the same as in the case when we are 100 kilometers away. So this is the first aspect. The second aspect is related with the detection or our ability to record this earthquake and and also the potential damage that this earthquake can have in the case when we are like 5 or 1 kilometer close to the earthquake or to the fault, and in the way that we are 100 kilometer away when we can feel only really, let's say, considerable earthquakes.
Oh, thank you for a really clear explanation. And now I understand why you handle media communication during actual earthquake responses. So, how do you manage to translate complex data like magnitudes and the risk to a scared public while the event is still unfolding, is still in the process?
Yeah, at first I try to relax the people, the community as much as possible, using kind words or using words that try to bring them peace in the sense that this is a natural phenomena. This is something that we cannot force it, we cannot stop it. So it's something that uh, it has happened and it will happen in the future. So we just have to keep our mind clear that this is something that we cannot stop it. So just this is the first step. And the second step, I try to gather as much as possible information regarding the area and start with analysis with let's say, understanding as much as possible the trend of this earthquake, and in this way try to find the positive aspects and to stick to the positive side of the phenomena in order to bring to the public the best uh, results that can bring calm to to them.
Wow, that's really great methodology that you're describing. So thank you for telling about it. Damiano, like me, you use Python and AI for trend detection. In the field like seismology, that has been around for over a century, uh, what is the biggest change that AI is bringing to how we understand seismic risk in Albania and generally all over the world right now?
Well, as much as I know, AI is being used for data processing. Like in particular, I have seen cases when we have used AI for automatic picking. So in a set of earthquake recordings, as an earthquake is as a waveform, and during this waveform, we take some peaks in order to locate the earthquake and in order to continue with the further analysis. So AI, in this case, is used for auto picking. This helps for comparing the uh, automatic picks from AI with manual picks. The first thing, and the second thing is that we use auto picks when we have large quantity of waveform data that cannot be analyzed manually by a human. So in this sense, in these two aspects, it's very useful because it can allow us to analyze a larger quantity of data. And in nowadays, where the data is increasing every day, AI, yeah, it's a really useful tool in today's seismology.
Yes, I totally agree with you. So now let's talk about your career journey. You hold a bachelor degree and a master degree in physics and not geology. So what was it about seismology that made you say, I want to apply my physics knowledge to the Earth? Was it a difficult transition to move from pure theory to sometimes messy field data?
Well, at first, during my studies, as physics, as you mentioned, not for geology, I didn't have too much information, like theoretical university information about earthquakes. I just knew something that this was a natural phenomenon. But it was one of the reasons was the big earthquake we had in Albania in 2019, 26th of November 2019. It was a considerable earthquake with magnitude 6.4, which caused a lot of damage. And I experienced that earthquake myself. It was a hard experience. So yeah, that was one of the reasons to go into seismology and to understand more about this phenomena. And regarding the transition, I would say every kind of transition, especially in this case from a pure theoretical background as physics to seismology, which is like applied field. Yeah, it has its own difficulties as any other interdisciplinary field. But the strong physical foundation from physics, it's a very uh, good foundation, I would say, in the field of seismology that has helped me with the basics understanding of this science.
Yeah, sure. Physics, geophysics, seismology is, yeah, basically you can very easily connect to them and transfer knowledge between them. So I actually have a question about a specific moment where you knew uh, that actually science. No, I would reformulate that. So take me back to times before you were a researcher. You now told me about the time when you really thought like about transition to seismology, but was there a specific moment, maybe a childhood memory or a specific teacher, where you knew that science, and in your case physics, was the path that you want to take?
Well, I have been always during my childhood interested in science, like how the things work, the universe, and physics in general. So it was like a early orientation of the things I was more attracted from, and also the teachers, the science teachers, all of them, most of them were very good, and they really gave the best in their subject, and this helped me to really go more into science field.
Wow, that's great because you're lucky with teachers, and it's a not given. So I mean, real grateful to them for making you a scientist that you are helping the world basically. But you now talked about positive sides like mm, good teachers and your curiosity. Let's now go a bit to the negative side. What was the single biggest hurdle, whether technical, logistical, or personal, that you had to overcome to establish yourself as a researcher in geosciences?
Well, I would say the technical part was the biggest one, I would say, because I didn't have any information from my theoretical background as physics, as you mentioned. It's quite theoretical, the physics that I used to study back into university. So the technical aspects, so like the sensors, the way the data is recorded, the way these devices are deployed, the way the data is extracted from them. So this process, I would say, is the one that really I didn't have any clue in the past, and I would say that's the one of the things that really was my let's say, or took my best of my efforts to understand.
Yeah, okay, well, it's natural and it's great that you overcame this hurdle. Um, Damiano, you are a unique geoscientist because you write Python code and you physically install the sensor in the fields. Many data scientists today never actually touch the hardware. Do you think knowing how the instrument works changes the way that you interpret the data?
Absolutely. Especially in the field of seismology, it's very important to really know the hardware, really know the sensors in the field, because, for example, in the seismic data that we usually analyze, there is noises that can come from human activity or animal activity. It can come because of the bad position of a sensor. So all these aspects, like when you deploy a sensor, you know them before getting the data and before starting to analyze the data. Since you know exactly about the hardware and about uh, the specifics of the site when the sensor is deployed, you know also other details that will impact the way you analyze the data. So it's very important, I would say, to know the hardware, because you have the full picture of the data, and your analysis in this way will be very full, and you will have uh, a very deep understanding of this data recorded, and then you will continue with an analysis confident.
Yeah, absolutely. And now I want to ask you a question that uh, many friends, knowing that I'm geophysicist, they ask me, and before I went to this area, was one of the most important question to me. So now I want to ask you about it. We are getting better at detection and early warning, but prediction of the earthquakes remains the holy grail of our field. So, as a physicist, do you believe we will ever see a proven method for deterministic earthquake prediction in our lifetime, or is the Earth simply too chaotic?
I don't believe we will get into a proven method for determine exactly a time and the space when an earthquake can occur, because I think it's a very complex process, so complex that it changes from uh, from place to place, and even if you determine some kind of prediction for a certain area, if you go into another area, it changes completely. So it makes it very, very hard.
Wow, that's not really optimistic, but it's true. I agree with you. But hopefully, the future in this sense is closer than you and I think about it. Um, so, um, Damiana, you communicate with the public in Albania, but let's imagine that you are standing at the United Nations tribune addressing families in seismic zones globally. If you had just 1 minute to explain the difference between internet rumors and real seismic risk, what would you say?
Well, I would say to the people that they should be they should intend to understand which are the right scientific authorities, like institutes or researching facilities, which have the ability to estimate the seismic risk. This is the first step. So we know that this is the right institute or authority. And the second thing is that internet rumors, it's not about earthquakes, it's about everything nowadays sometimes. So just to try to focus into these authorities, to identify these authorities, and just to try to trust the science they are doing, because of course they cannot say when it's going to be the next earthquakes, like a prediction, but they can do the best for the future, for the building constructions codes, so that the buildings can save the people's lives. Because the earthquake, even if you someone uh, can think about earthquakes, but they cannot be stopped in any way.
Yes, I agree with you. Finally, looking at the next generation of researchers, in just one single word, how would you describe the future of the geosciences?
I would say in single word, only data. uh, the geosciences is related with data, the past data and the future data. So just keeping the data and understanding what we have had and what we have now is the most important thing, because it's a science that it's based on the past. So the data we have from the past is the biggest and the most important foundation that we have in geosciences.
Yes, it's all about data nowadays. So, Damiana, thank you so much. Your work keeps people safe and pushes our science forward. And I really appreciate your time. Thank you for talking to me on our project, Geoscientist Voices.
Thank you. Thank you very much for the invitation.